Okay, so good evening, everyone. Those who have joined new today, let me introduce myself. This is Saravanan, Prime Minister Research Fellow and PhD Scholar of Department of Civil Engineering in NIT Tiruchirappalli. So, I am taking this problem solving session for the course Wastewater Treatment and Recycling. So, this is a part of PMRF TA ship. So, we are in the week 10 of this problem solving session. So I have also taken four more NPTEL courses, problem solving sessions for last 3 years, consecutive 3 years in air pollution and control, solid waste management, as well as for plastic waste management. So this is my fourth course. So in the last 9 weeks, we have discussed about what is that wastewater and why we need to treat the wastewater and what is wastewater recycling. So initially to know about this, we have assessed how much quantity of wastewater that is going to be generated. For that, we have calculated the population. Based on that, the wastewater that is going to be generated was calculated. That is a quantity assessment. In the second week, we have discussed about the qualitative assessment. That is the characteristics of the wastewaters, both physical, chemical, as well as the biological parameters of the wastewater. In the third week, we have discussed about the natural purification process. So once the wastewater is generated, if it is disposed in the surface water bodies like a river or lake or pond, what will happen to that water bodies? What are the natural purification system or the process that will happen to reduce the impurities in the wastewater? If the wastewater parameters are more than the limit, then it is the problem to the environment as well as the human health. In the fourth week, we have discussed about the treatment philosophies. There we have discussed how the reactors will work on the batch reactors, continuous flow reactors, the plug flow reactors, and different problems we have solved based on that treatment principles. In the fifth week, we have started with the treatment process. First, we have started with the preliminary treatment process. There, we have discussed about the screening process, equalization and neutralization tank, grit removal, and in the primary treatment system, we have discussed about the sedimentation. So here we have removed most of the coarser particles such as the soluble matters like soluble organics and inorganics we have removed in the primary sedimentation tank itself. In the secondary treatment, we have left over with this soluble organic matters. So suspended particles we have removed in the primary system and soluble particles we have removed in the secondary treatment systems. So in the secondary treatment, we have majorly focused on the ASP, that is the activated sludge process, and the kinetics of the biological process that what we have discussed in the seventh week. And the eighth week, all this process have generated mostly sludge, even from the grit chamber, from the primary settling tank, from the secondary settling tank, all are sludge. Mostly aeration process will have sorry, I mean aerobic process will have 60% of sludge formation. So that we have removed, and management of this sludge plays a major role. There we have studied about the sludge dewatering, sludge conditioning, sludge drying, and sludge disposal. In the ninth week, we have started with the tertiary treatment. That is the advanced treatment for the treated effluents. There we have focused on the dissolved inorganics like salts, microplastics, this type of emerging contaminants we have discussed in the ninth week. There we have discussed about the nutrients removal also, both nitrogen and phosphorus we have removed with the aerobic as well as anaerobic process in nitrification and denitrification processes. And advanced treatment process like advanced oxidation process, absorption, membrane technologies we have discussed. Now we are in the 10th week. We are going to discuss about the current treatment approaches, because ASP are in progress for last 2-3 decades. Now we are in the advanced treatment approaches. So we are going to discuss about the latest technologies. This is also not latest. The research are already saturated, and we are in the field like MBR, MBBR, SBR, SBBR, and most of the RO membranes we are going to discuss today, and along with the wetland systems. That is also one of the constructed wetland is one of the mimic of the natural treatment system. Okay, that's what's today's agenda for the wastewater treatment 10th week. Let me go through the lecture material. So the class was originally taken by Professor Manoj Kumar Tiwari sir of IIT Kanpur. Now he is in IIT Kanpur. Earlier he was in IIT Kharagpur. So all the material credits goes to him. So first 1 hour we are going to discuss the same lecture material what sir has discussed, and another 1 hour we are going to discuss about the problems, that is the old assignment problems. Okay, so let's move on with the options and conventional approaches for wastewater treatment systems. Earlier we have discussed about the different treatment technologies, how to integrate this type of different technologies. Like we have studied separately about ASP, we have studied separately about nitrification and denitrification, we have studied separately about primary settling tank, how to integrate this system. For example, if you take the Nagpur's 200 mld STP, there we have an integrated primary settling tank, secondary settling tank, that is a parallel to secondary settling tanks, along with the aeration tank, then followed by sludge management, sludge digester tanks, and sludge dewatering, drying beds and all we can see in this whole aerial view of Nagpur STP. Similarly, if you see most of the industrial units, this is one of the picture from Washington in US. They have a Blue Plains wastewater treatment plant. You can see how the tertiary treatments are going on in the STPs in abroad. So several unit operation and unit processes we have discussed about this. Unit operations are physical treatment of wastewater, and unit processes involves biological as well as chemical treatment of wastewaters. So this several unit operation and unit processes will be integrated together to get this a whole wastewater treatment system. You got it? So this is what we are discussing for the last 9 weeks. First preliminary, that is screening and grit removal, and primary focuses on the primary settling tank or sedimentation. That is a major approach to remove the suspended inorganics, and the secondary treatment plant focuses on the soluble inorganics. There we have activated sludge process, trickling filters, rotating biological contractors, membrane bioreactors, and all will come under secondary treatment plant. Based on low rate or high rate process, we can also classify it into stabilization pond, aerated lagoons if the quantity is very less. If the quantity is high, like urban areas, we can go with the ASP process. Okay, so in advanced treatment system, we can go with the nutrient removal first, that is by nitrification, denitrification, chlorination, and phosphorus removal. Similarly, we can go with the biological as well as the chemical methods. Biological, we will go with the phosphorus accumulating bacteria or PAOs, phosphate accumulating organisms, and in chemical treatment system, we can add lime and alum to precipitate the nutrient in the wastewater. And suspended solids removal by filtration, that is membrane filtration, we can go with. Last week we have discussed about different types of membrane, from micro, ultra filtration, nano filtration, and RO we have discussed, and membrane fouling also we have discussed. And dissolved organic removal by softening, electrodialysis, nano filtration, and RO. Finally, we can also go with natural processes like simple constructed simple wetlands, or along with these constructed wetlands also we can go. We have less space, so that will reduce the land footprints. Finally, before disposal, we have to go with the disinfection. Yeah. So how this choices can be selected. All are based on how much degree of treatment you need. So if you are going to dispose in a river water, in a particular stretch we are going to extract for drinking water, we need a high level of treatment. Or if you are simply going to dispose in the ocean, so there the degree of requirement will be, the treatment requirement will be very less. So you can follow with the EPA guidelines for the disposal of effluents. Based on that, where we are going to dispose, if it's the inland surface water or in a marine or in a land or in agricultural soil, where we are going to dispose the treated wastewater, based on that we can decide which treatment plant we are going to choose. And the regulatory requirement, as I mentioned, every local bodies have their separate bylaws. Based on that we can treat the wastewater. Then the budget availability, cost, both in operational as well as the capital cost. Land availability is another major issue. Based on that the system will change. And the skill available, climatic condition, because most of the bacterial biological process will work with the optimum temperature conditions. Mesophilic bacteria will work more it at 20 to 35 degrees Celsius. So we have to maintain that required temperature to achieve the maximum degree of treatment. Then technical reliability, social acceptance. There is a underlining factor, social acceptance, where we are going to choose the plant, or who are the people they are going to object before getting the impact assessment or the public concerns. Finally, we are going to sequence the various treatment systems. Before initially, we are going with grid system, primary settling tank, secondary settling tank. Before secondary and primary settling tank, we need to insert an aeration tank. So this sequencing matters. So which need to be treated first? Initially, we have to remove the coarser items. That will help in not to repair the further treatment system. So that is the major thing. First you have to remove the coarser particle, then you have to remove the finer particle. Finally we are going with the dissolved particle. So that sequence matters. Sequencing of various treatment units is an important point in designing the wastewater treatment plants. So conventional ASP will work with the raw sewage collection, screening, grid chamber, primary settling, followed by aeration tank and secondary settling combinedly called ASP, where we have a recycling of sludge. Finally, the sludge will be taken to the sludge digestion tank. The tertiary treatment, if you want, we can go, or the sludge disposal. Got it? Or you can go with the conventional UASB treatment, where the wastewater after preliminary treatment. Secondary treatment, we can go with a anaerobic upflow anaerobic sludge blanket reactor. This also we have discussed. The wastewater will be flowing from bottom to top through a sludge blanket. Here, the sludge blanket will act as a biological treatment process anaerobically, and lots of biogas will be produced. That gas will be trapped and can be used for further applications, and the clean water can be taken out. So this is also we have discussed in the earlier lectures. Now we are going with the integrated systems. First is the wetlands. So what are the alternate treatment system to the conventional wastewater treatment system? Can you look into different alternatives? We can mimic the natural process itself. See, the new systems are being developed relying on the standard physiochemical and biological process, optimizing this treatment efficiency to reduce the cost and the energy consumption. Because ASP, we need a recirculation that achieves only 70%. If you want 90%, what can we do? If you want 99% of treatment, what we have to do? So this type of treatment efficiency matters, and cost and energy consumption again a major concern. So that based on that we can choose alternate treatment options. So more applicable to decentralized sewage treatment plant, we can go with a smaller modular kind of things. Nowadays modular kitchens are very famous, right? Similarly, modular treatment systems you have to go based on the land availability. So this type of alternate systems you can choose. See, constructed on natural wetlands, sequencing batch reactors, sequencing batch biofilm reactors, membrane bioreactors, and moving bed bioreactors. Think about all this we are going to see in this whole 40 minutes from now. So what is natural wetland? The name itself mentions the land is wet. So it's mostly a kind of lake or a pond. But mostly it will have a good bio ecosystem, a good rich bio, what we say, uh, whole bioecosystem will be there, like plants will be there, aquatic organisms will be there, all will work together to remove the nutrients as well as the organics in the wastewater. So wetlands are called as Earth's kidney, because whenever there is a wastewater passing through the wetland, it will purify the wastewater and it will give you the pure water out. That's why this type of wetlands are called Earth's kidney. How the forests are called Earth's lungs. Like that, it's purifying the air, right? The carbon dioxide it's taking up and oxygen it is releasing. Like that, wetlands are called as Earth's kidney. It will filter the pollutants from the water and the wastewater. So the same principle we can adapt for a constructed wetland, that's called artificial wetland. This type of wetlands are available in most of the areas like marshland or kind of things. You can see Ramsar Convention. I will also go through some of the reading materials I will upload in the Google Drive. You can say Ramsar Convention. They are organized to protect the wetlands. In Tamil Nadu itself, we have large number of wetlands, conserved wetlands we have. So Ramsar Convention have lots of conserved wetlands to prevent the Earth's ecosystem. Similarly, we can follow the same principle by constructing a wetland. That's called artificial or constructed wetlands. So this engineered system will replicate the function of the natural wetland by utilizing the natural process. What are the natural process will happen? Like absorption, filtration, hydrolysis, biodegradation, bioaccumulation, uh, phytoremediation and photoremediation. So you all see this. This have lots of soil bed. So that soil bed will act as a filtration media and absorption media, as well as the water in the wetlands will act as a hydrolyzing agent. And bacteria or a microorganism present in this wetlands act as a biodegrading catalyst and bioaccumulating catalyst. And phytoremediation, because of the plant can uptake most of the nutrients through its roots, so it's a phytoremediation. Then photoremediation, direct sunlight can act upon and degrade the pollutant. That's a photoremediation. So all these principles will happen in a simple natural wetland. How can we replicate the same principle in a constructed or artificial wetlands? So that pollution removal mechanism in wetlands is a major concern. See, first the suspended solids, if you take, that can be removed with the sedimentation or filtration process. How? Because the bed underneath will act as a filtration media or a sedimentation basin. Similarly, the soluble organics can be removed by aerobic microbial degradation. What's happening in the ASP tank? Microbes will eat the soluble organics and it will grow. Similarly, the aerobic micro degradation and anaerobic microbial degradation will happen in the wetlands to remove the soluble organics. How both aerobic and anaerobic is happening? The top surface is having aerated surface, and the bottom, if you go, it's having anaerobic condition. So both aerobic and anaerobics are happening. That's why in the aeration zone, nitrification is happening, and in the anaerobic zone, denitrification is happening. So both the nitrogen and the phosphorus will be removed from the wetland. So wetland can be act as a aeration as well as the anaerobic reactor system. So matrix absorption, plant uptake, denitrification, nitrification, ammonification, everything happen in the wetland. A simple wetland with the help of plant can remove the nutrients. Then metal, how can we remove metal in wetland? Again, the same principle of precipitation, complexation and absorption and cation exchange. Because soil will act as a cation, it has a good cation exchanging capacity, so it can remove the metals from the wastewater. Then pathogens, if you think, pathogens can also be removed with sedimentation, filtration, or how the RO membrane can remove the microorganisms. Similarly, this type of bed filter act as a filter and remove the pathogens. And photoremediation, as I mentioned, sunlight can act as a UV irradiation for the treatment of pathogens in the wastewater. Think about the constructed wetlands that we have. It offers a better control over the hydraulic pathway and retention time compared to the natural wetland. Because natural wetland we can simply dispose the wastewater, but the effluent quality we can't control. But in the constructed wetland, we can control how much inlet, how much outlet, what is the time requirement, that is the hydraulic retention time, and the pathway. If it is going vertically or horizontally, that can and all we can control. That's a better control over the parameters, operating parameters in the constructed wetlands, and it provides a flexibility in site selection and sizing. Because if you have only smaller area, then you can go with a smaller wetlands with a higher lower HRP. What are the components of this constructed wetland? We need a substrate. So what will act as a substrate? The wastewater. Then the vegetation. Vegetation will act as a phytoremediating agents. So plants are required mostly. So what are the plants we can use nowadays? Now we have our research group is mostly working on constructed wetlands. So they are working on different canna indica plants and other type of plants that can easily grow or uptake the nutrients. So that type of nutrient removal efficiency is higher for different types of plants. That vegetation we have to choose. Then inlet and outlet for incoming and taking out the effluent. That the liner system to safeguard the groundwater at the bottom. Then the basin. So this basin will act as a reactor. You got it? So we have an inlet outlet system. We have an underlining system. We have a substrate that is a wastewater along with the medium. So this soil will act as a medium and the plant growth. So these are the whole setup for the constructed wetlands. So how we classify the constructed wetlands based on surface flow or subsurface flow. So subsurface flow means water we are putting at the top, it will flow through the soil. So if it is going horizontal, flowing horizontally, then it is a horizontal subsurface flow wetland. If it is flowing vertically from the top to bottom, then it is vertical subsurface flow wetlands. Again, vertical can be classified as downflow, upflow, and tidal. If you think about surface flow, emerging plants, submerged plants, free floating plant, and floating leaved plants, because everything is happening, the plants are growing at the top of the water surface. We don't have any soil medium. So that is a surface flow condition. If you merge both surface flow and horizontal flow, that is a hybrid system of wetlands. See this diagram? So this is a subsurface flow. Water is going there and then horizontally it is moving and it is collected at the right side. Similarly, here the water is pushing from all the parts and then it is coming out. So it's a vertical flow. Then if you see, this is a hybrid tower type. There both aeration also happening and then this vertical as well as horizontal it's happening. This type of combination hybrid also we can choose. And here circular flow corridors. So from here it will go move through different compartments of different reactors and it will be treated based on the conditions. So that is one of the hybrid system for the constructed wetlands. See, as I mentioned, there are three major types: free water surface, vertical flow, and horizontal flow, or subsurface. So if you see the free water surface, sand medium will be at the bottom, water will flow at the top. So the plant will maybe floating at the water or it will be tied with the soil. So this will be replicating the naturally occurring process such as wetlands, marshland, swamp. So the plant will utilize all this nutrient in the wastewater. We can use wetland as a because if you are using wetland, the organics may or may not be removed or it can also be increased because of the addition from the plant. The nutrient removal will be very high because the plant will take the nutrient from the wastewater. So we can use this as a tertiary treatment system. If you say subsurface flow, it will be again classified into horizontal and vertical as I mentioned. Water will be pushed from top, that is dosed from top to bottom, that is dosed on the surface from above. So water will flow vertically and it will reach the bottom. The whole bottom liner will have a pore to collect the effluent. So it will be collected in the pipe and it will go to the right side. That's a vertical flow. If it is a horizontal flow, the water will go the whole way horizontally and it will be collected at the right side. So here absorption will be very high. So the large gravel and sand filled basin. So this type of basin will act as a absorption as well as a filtering medium. And then hybrid, if you see, vertical as well as horizontal will be combined and both surface and the subsurface flow can also be combined in the hybrid constructed wetland systems. So what are the design configuration? The life forms of the dominating macrophytes, like which type of plant you are going to use and where is the plant is going to grow, at the top or at the water or at the soil, like that we have to think. Then flow pattern, horizontal or vertical or free flow. Then type of configuration like hybrid, one stage or multi-stage. Then wastewater, what is the wastewater you are going to treat? Treatment level, type of pre-treatment and influent and effluent structures, type of substrate, because we can fill with gravel or we can fill with the sand or soil, that and all we have to think about. Then type of loading, it can be a continuous or intermittent loading in the constructed wetlands I am saying. Okay, then what is the advantage of this type of constructed wetlands? it is very less expensive because it's maximum based on the natural treatment processes. Now, no mechanical or any power supply is required except the flow. So, utilization of natural process, simple construction, simple operation and maintenance, cost effective process stability. So, these are all advantages of constructive wetland. But the limitations are the larger land requirement. If you are going to plant the whole instead of a single tank, you have to go with a bigger land. So that is a land requirement in the constructed wetlands. So you can optimize the process with the different hybrid technologies. Then design criteria have to be developed for constructed wetlands. So you can follow this type of guidelines for the wetland construction. We have a constructed wetland manual by the United Nations Human Settlement Program, and we have a handbook for constructed wetland by US EPA, and they have also provided a constructed wetland treatment for municipal wastewater and for the wildlife habitat. So this four I have downloaded and given in the problem solving session. What we say? 1 second, I will open and show you. So in the PMR of problem solving session, you can see the. So if you go to the problem solving session, I have uploaded in the Google Drive the reading materials, constructed wetland manuals. Here you can see all the four manuals. You can read and go through how the design criteria and all. Okay. Then alternate wastewater treatment system. We are going to see about the SBR, SBBR, MBR, MBBR. Okay. The name itself, it will be indicating the whole process. What is sequential batch reactor? SBR. Sequential batch reactor. So the name itself indicating it's a batch reactor. What is batch reactor? I will take the pen. So the water will come, it will be treated in the tank, and water supply will be stopped, wastewater supply will be stopped, it will be treated. After treatment it will be taken out, and then again second batch will come. So that is a batch treatment. In a continuous treatment, water will continuously coming in, water is continuously going out. So the treatment will be happening within this time period. So here there is a retention time, here there is a retention time. So based on that we can divide the batch reactor and the continuous flow reactor. What is plug flow reactor? It's kind of a pipe flow where the treatment is happening at the different levels. So here any time the concentration will be varying at a different time, and it can be taken out at the required time. Here at any time the concentration will be same in the continuous flow reactor. That's the concept of reactors. In the plug flow, at any point the concentration will be same, but at a different point the concentration will be varying. That's what, and steady, but through space it will be varying. So dou C by dou T will be similar, dou C by dou S will be varying. So that's the concept of plug flow reactors. You got it? So we are mentioning about the batch reactor. ASP is a continuous reactor, right? We are having a aeration tank. Water is coming in, water is going out. We have a sedimentation tank. Water is coming in, water is going out. So what is the wastewater we are putting in? What is the wastewater, the effluent that is coming out? So the whole system is called ASP treatment system. That is the secondary treatment, continuous flow. The same if you follow in a batch mode, then it is called a sequencing batch reactor. What is the sequence we are going to follow? Process are operated at a batch. Like fermentation, biodegradation, separation, everything happen in a same reactor. We don't want a aeration tank, we don't want a sedimentation tank. Everything happening in a single reactor. How? First we are filling in the tank and we are stopping the flow. So that is a batch mode. Here we are mixing and aerating. So that mixing and aeration will help to react. Similar kind of aeration tank. After reaction, the aeration and mixing will be stopped and it will be allowed to settle. So similar to secondary sedimentation tank, all the solids will settle. After some time, the clear water at the top will be taken. That is called a decant. After taking out, some sludge will be wasted and some sludge will be retained for the next cycle. So you got the sequential batch setup. It's a sequential cyclic reaction happening in a batch reactor. That's why the first step is fill, having mixing and aeration. Second step is react. Water will be decanted. There also no mixing and aeration. Finally, the sludge will be mixed and aerated and some will be wasted. That's the ideal condition. Fill, react, settle, decant, ideal stage. You got the whole system. So that's the sequential batch reactor. For every step we are going to see. First, fill. So the basin receives the influent wastewater. It is receiving. So how to fill different filling itself? We have three different types: static fill, mixed fill, and aerated fill. So as I mentioned, filling, whether we need mixing, whether we need aeration, based on that we have three type. Static fill means there is no mixing, there is no aeration. So there is no mixing, there is no aeration. Simply the water will be filled. That's a static fill. Mixed fill means water will be filled and mixer will be on. That's the mixed fill condition. Aerated fill means both aeration and mechanical mixer will be on. So air will also come, mixing will also happening, and filling will also happening. That's called aerated fill. So based on the filling mechanism, you can differentiate the fill: static fill, mixed fill, and aerated fill. Then the second step is reactor. Right, in the same reactor only the reaction is happening. For reaction to occur, it will have a mixing and aeration. Right, so that the biochemical reaction will happen to remove the carbonaceous BOD. If you lot of time, then nitrification will also happen, nitrification, denitrification, because if you stop the aeration, you can make this reaction itself. The third step is settle. Both the mixing and the aeration will be stopped, and the flocculated microorganism will be allowed to settle. So it will form a blanket of sludge. So that is called settling. So clear supernatant will be taken out. This is a quiescent condition. Quiescent means very ideal. There is no mixing, no aeration. The calm condition. You got it? So the sludge blanket will settle at the bottom, and it's a critical part because you should not disturb the settled thing. If you start mixing or anything happens, the settled particle will again come into the water. So it should be taken care very carefully. Then decant. Decant is also the problem because we are taking out the clear water at the top. Settled sludge will be here, clear water at the top, and we have to take the water out without disturbing the settled sludge. So we can use a decanter. Decanter is kind of a pipe with holes that will have a vacuum pressure and take out the water. We can use a floating decanter that will float on the tank and it will take the water and the level will be reduced. Or you can have a fixed arm. That the arm will go down and it will take the water. Similar kind of floating and fixed arm conditions you can use to decant the water. After decanting, you can switch on the mixer and aerator so that the sludge alone will be mixed, some will be wasted and some will be used for the next cycle. So that's why the whole 5 cycle will be fill, react, decant, fill, react, settle, decant, and ideal condition. You got the whole setup here. See, the feed is happening. There, substrate will be given as an input, and reaction, during this reaction, carbonaceous nitrification will also be removed, nutrients will be removed. Then settling phase, there clarification will be happening because the solids is settling, right? So clarification. Then decanting, that will treated water will be removed. Finally, excess sludge will be taken out. That's called ideal condition. Shifting from ASP, that is a conventional process, to SBR process. Why? Because in aeration we needed two tank. One is aeration tank, one is a settling tank. In SBR we need only one tank. So that land area will be very less. High effluent quantity because all are happening in a single tank. So settling will be good. Both, if you can change it to nitrification, you can change it to denitrification. You can do anything in the same reactor. So high effluent quantity, fully atomized. So that is a good thing. In aeration and in the ASP, we can't control the process as much as doing. But in SBR, we can control will be more. Then resistant against shock load. Whatever you are giving, you can change the level of sludge retained. Based on that, you can resist the shock loads. But the disadvantages is continuous supply of energy is required to decant, to take the water, to fill the water. So continuous flow, there is no much energy required. So that are all disadvantage. And highly mechanized equipment, if anything fails, the whole treatment plant will be stopped. So that is all disadvantage of SBR. So we are going to SBBR, same sequential batch but biofilm reactor. Why we are using the biofilm? Here the plant, the microbial growth in this SBR will be in the tank itself, the bacteria will be in suspension condition. But in the SBBR, I'm adding a plastic medium, a kind of plastic cap or something. In that plastic medium, the bacteria will grow, so that the plastic medium will be in suspension in the same SBBR condition. So the SBR will be combined with the biofilm growth. Sequencing batch biofilm reactor used as carriers. Carriers are the plastic medium I am saying. Na? So they have a high surface area. Biofilm will be growing on the surface. So that have the advantage of both attached growth system and suspended growth system. ASP is a suspension growth system. Trickling filters are attached growth system because we have water from top spraying, and it will be the microbes will be attached to the medium, and it will filter the water or treat the water, organics in the water, right? That is attached growth system. ASP is a suspended growth system. We are merging both and having both suspension and attached growth in the SBBR system. But the tank is a single tank, right? After that, the carriers will be settled and water will be taken out in the same reactor. Again, we can mix that medium. Next, we are going to MBR because the settling, if it is not proper, that is a problem. So, how to remove that sludges? We can have a membrane. So, that membrane will stop the sludges from the SBR, so that only the water, pure water will come out. No need of settling. All the solids will be retained in the left side, only the water will come after reaction. That can be acting as a continuous reactor. So that is called MBR. So membrane bioreactor. M stands always for membrane in biological, right? So combination of suspended growth and biological treatment system along with the membrane filtration equipment. So see the same ASP, because we are aerating, all the microbes will be taking air and it will degrade the organics. So water is always coming in. But instead of settling the sludge, we are filtering the sludge with the membrane. So that semi-permeable membrane will, like any microfiltration or ultrafiltration, you can choose. So through the pores, only the clean water will come out. So that kind of filtration technique you can merge with this suspended growth system, so that the sludges can be retained in the aeration tank. Only the clean water will come out. You got the point? That is the MBR reactor. So here the membrane can be replaced with a secondary sedimentation basin. So in ASP we have a aeration tank and a sedimentation tank, secondary settling tank. Here both can be used as in a single tank, but we need a membrane to filter. Right? Secondary sedimentation can be replaced with a membrane. That's why membrane bioreactor. Here the operating higher sludge condition 10 to 20, because all the sludges are not settled, it's retaining in the system itself. So high sludge concentration, high removal, good effluent quality. That is the major achievement with the MBR at a low reactor volume. Even with a smaller volume of tank itself, we can remove good with good efficiency. That's why high sludge concentration increases the that is another problem. If you have high sludge, we need high oxygen. So we need to have a good modern aeration system can be recommended to supply high oxygen content. Otherwise, this will become very viscous and thick because it's a high sludge concentration, right? It will be thick. To penetrate this thick sludge, we need a modern aeration system. See here, the membrane can be outside, or the membrane can be inside the reactor, or the membrane can be outside inside the another reactor. You got it? Here the aeration and reactions are happening, and the water will be taking out along with the sludge, and only the pure water will come out through the inside the tank. Reaction is happening. We are applying a vacuum pressure, so that pure water only will come inside the membrane and it will be taken out. In this reactor, aeration is happening in the tank, but it will be taken to the another tank where the again aeration is happening, but the membrane is in the another tank. Side stream. It's a side stream only, but air lift. You got it? So based on where we are placing the membrane, we can classify the MBR into different configurations. See the external configuration type. The membrane module is outside the bioreactor. The simple aeration tank only, but the membrane is outside to filter. Similar to secondary settling tank, we have a membrane. So easier membrane replacement we can do, and high flux condition, high energy consumption is required because we have to suck the wastewater from here to here, pump the wastewater from here to here. But in the immersed condition, we can apply a vacuum to take out the, this is the driving force is, you have to apply a pressure from this side or we have to apply a vacuum from inside. So both will work out to take out the clean water. Here less energy consumption, less rigorous cleaning process. There cleaning process will be very high because of the lower tangential velocity. Here, see, another third part is the airlift side stream. Same bioreactor is there with the aeration, and another reactor with the aeration, but membrane will also be there in that reactor. So that is the airlift side stream configuration. So it is a robust advantage, advanced technology having low energy consumption submerged system. So the problem is membrane fouling. What is membrane fouling? All the membranes have a pore, right? If you think this is a membrane, it is having a pore. So small pore will be there. Through this pore only water will come out. If the pore got clogged with the microorganism, the pressure requirement will be higher or effluent will not come out. So this clogging of membrane is called membrane fouling. So major drawback of MBR is reduces the membrane performance and membrane lifespan attributed to the suspended particle that will collide, solute and large flux deposit on the membrane and it will clog the pores. It will decline the permeability. Initially the permeability will be very high after cleaning and then the permeability will be reduced, so the clogging of pores will happen, so the effluent quantity will be reduced. So we have different forms of fouling like pore narrowing, pore clogging, cake formation. See here, a new membrane have good pores, water can easily go, permeability will be very high. But when the microbes starts growing, it will start attaching to the pores. See, that is a pore narrowing. Initially, it will be big, like a 2 micrometer. Now it got reduced to 1 micrometer because of the deposition. Similar, if you see the cross section, any pipe, if you see salt will be deposited and the size will be reduced. So water will be supplied more earlier. Then if you have a lot of salt, then water will be flow will be very less. That's similar kind of thing. Pore will be narrowed here. If the whole pore will be clogged, then it is called pore clogging. If the whole membrane is having a surface of microbes, then it is a cake formation. Once the cake is formed, the bottom layer will become anaerobic condition and the bacteria cannot survive because it's aerobic bacteria. That will detach the membrane. Whole cake will be taken out. That is called cake. What we say? It's a tearing process will happen and the cake will come out, so that again the pore will be clear and permeability will be high. So pore narrowing, pore clogging and then cake formation will happen. So this kind, what are the things will clog? Sludge will clog, extracellular polymeric substances produced by the microbes or suspended microorganism particles or fine colloids that will clog this type of membranes. So what are the factors that will affect the membrane fouling? Feed into biomass property. What are the wastewater we are giving? Based on that, it will like what are the MLSS concentration, flock size, alkalinity, pH, salinity, because salts may also deposit in the membrane. So this inlet wastewater condition will affect. Then the membrane property. What are the membrane property? Which membrane type? The membrane having a good affinity or not, roughness, surface charge of the membrane, pore size of the membrane will play. Then finally the operating conditions like the time, the SRT, HRT, FBM ratio, all these physical and biological properties will affect the membrane fouling. So how to retard this membrane fouling? We can add some anti-fouling measures like air-induced cross flow or gas bubbling, intermediate permeation and relaxation, particle deposition and diffuse back to the reactor. Like we can add some water from the other side and we can flush out the what we say like the flocks, and then chemical assisted backwashing, and then we can use the air jet to remove that, and then anti-fouling products. These are all anti-fouling measures for retarding the membrane fouling. So what is the advantage of membrane? membrane bioreactors, it is compact because we have only one type. Inside itself, we can use the reactor membrane also. High effluent quantity because we are filtering, instead of settling, we are filtering the microbes or sludges. So water quality will be very high, whatever the quality of effluent coming. High volumetric load we can operate. Secondary clarifier is not required and possible to convert it earlier. The same aeration tank in the ASP can be converted into a membrane bioreactor by inserting simply a membrane, right? So easy to convert in the already existing ASP plants. But the disadvantages is aeration is limited, high cost because the membrane need to be replaced often because of fouling, need equalization tank because the membrane can operate at equal level of conditions. So steady state is required, energy intensive process because we need to apply a vacuum pressure to take out the effluent. So that is an energy intensive process. But where can we apply this type of MBRs? For advanced wastewater treatment plant, high strength wastewater on-site reuses operations. Like in Tamil Nadu and all, we have a zero liquid discharge policy. So industry should treat their own water and they have to use for their application before discharging into the, I mean, they should not discharge even a single drop of water into the out of their industry. So they can use MBR or this type of membranes to treat their water and take out the pure water and use in their production line. That is a good application on on-site reuse options. Then this nowadays I am seeing in lots of industries as well as in municipals, MBBR, moving bed bioreactors. See here, similar to MBR, we have a continuous flow. It's not batch, it's a continuous flow. As I mentioned in the SBBR, if we have a plastic medium, in the plastic medium, microbes will grow. We have aeration, so the plastic medium will also float, but there is no sludge because all the microbes are present on the surface of the, there is some microbes on the suspension, but most of the microbes will be attached to the plastic media and it will eat the organics in my wastewater, right? So this plastic will not come out along with the water, so it will easily settle and sludge will be attached to it. So that is moving bed biofilm reactor. The bed is moving, right? So it's a combination of biological treatment method, ASP method, and bioreactor filter. Biofilter processes. This is the plastic media I'm talking about. So it can be any inert media with a high surface area because the bacteria have to grow everywhere. We need to have a good surface area of materials. Density close to water, then only it will be in suspension. So water's density is 1 gram per centimeter cube. So HDPE you can use, that is having density of 0.95 gram per centimeter cube. Surely it will be in suspension, right? So that is the principle you have to think before choosing the biofilm carriers. These are all called carriers. So in MBBR, where can we apply high density population of bacteria, that high rate of biodegradation will happen because instead of bacteria are in suspension, I am giving a media to grow. So more bacteria will grow, more degree of treatment. So no need of FBM ratio because microbes will be attached here. Self-maintaining of optimum level does not require backwashing. And the carrier will be mixed in the tank during aeration and mixing itself. So no need to apply a separate mixing condition. It will be easily mixed during aeration itself because it's having similar density to water. It will prevent clogging because if you add membrane, that will clogged by solids. But if you use carriers, the sludge will be in the carrier, so it will not affect the filter. So membrane fouling or clogging will be prevented. Maintenance of MBBR includes screening, influent equalization, clarifier system, and sludge handling. That's the major maintenance you have to follow. See the MBBR, anaerobic MBBR we have, MBBR aerobic we have. So to do the denitrification initially, and then with the nitrification and organics removal. So you can use any combination of this to achieve the nutrient removal and organics removal. So the MBBR advantages is low power consumption, upgradation, flexibility, and aesthetic. But the disadvantages are the media. How much time we have to replace the lifetime of the carrier media, and the other problem, high running costs. These are all disadvantage of the MBBR system. But how the MBBR system is experienced in India, we have it's ranging from like a 10 meter cube per day to several MLDs we can treat with this MBBR system, MBBR system. MBBR system. Newly developing townships, we can follow the semi-urban regions, rural regions, we can use MBBR because it's reducing the space footprint, less land area only required than the conventional ASP systems. Adaptation of MBBR is reported to reduce the solid load because sludge itself, it's forming 60% means how much quantity of sludge we will treat. We have calculated, right, like 1000 tons, 2000 tons per day, or 1000 kg per day. This much sludge where we will dry and dispose. But MBBR will have less solids load. So that is a good uh, advantage, right, with MBBR. Then the same limitations of MBBR is oil and grease, if anything is there, that will not work. And the clogging, because of the non-availability of primary sedimentation. If you have a primary sedimentation, easily you can use the MBBR, but again it will increase the land area. Dissolved oxygen is very essential, so we have to supply a large quantity of oxygen for the nutrient removal also can be claimed with the MBBRs. So this is the success stories of MBBR in Indian conditions. So today we have discussed about the actual treatment system, the next level approach than conventional treatment plan. Like we have adopted the same natural wetlands into constructed wetlands. Constructed wetland we will call CWOs. Then sequential batch reactor, we have used the batch treatment system with 5 reaction on the same tank. Instead of ASP, we have used the same tank for all aeration, sedimentation, everything we have followed. In the sequential batch reactor itself, we have followed SBBR. We have a bioreactor film in the same SBR to use as a sequential batch biofilm reactors. Then we have used membrane, so membrane bioreactors. That we have a MBBR system. Here, one second. Why it's called a moving bed is the bed itself moving. That's why it's called, the name I forgot to tell you. The bed itself moving. That's why it's called moving bed bioreactor. See the name itself, if you see, sequential batch reactor, sequential batch, biofilms are there. That's a carrier. Similarly, here also moving bed. That's the biocarrier. Same carrier what we are discussing here. Bioreactor. Membrane bioreactor. So, we are having a membrane but a bioreactor. This both are batch reactor, this both are continuous reactors. You got the whole idea of today's lecture. If you have any doubt, please unmute and ask, or you can post in the chat box. Sir, please. Hello? Sir, do you have any doubt? You have unmuted, I guess. Hello? Okay, if you have any doubt, please post it in the chat box, or you can unmute and you can ask. Otherwise, let me go through the problem solving session for today. Please post the answers in the chat box. I'll read through the old assignment problems. These are all simple topics only today, so you can easily finish it off. Can I read, or please post the answers? In a conventional STP, let me take the pen. Based on the aerobic technology, aeration tank is placed in. So in a conventional STP, we have a whether the MBBR is advance of MBR. Actually, this all research are happening on a similar kind of same decade. All the research were going on, and it's saturated. Actually, now the people are working on the field with this type of things. So we can't say which is advanced or which is conventional, which is older, which is advanced. But based on the degree of treatment required and based on the cost availability, you can choose. If you have a membrane, you can go with the MBR. If you have a plastic carrier media, you can go with the MBBR. So the efficiency will be more for MBBR. So I can say MBBR is advance of MBR because the efficiency is more for MBBR. Yeah. Let me start the. Hope it's. Hope I cleared your question. Yes. Okay. We will move to the question here. So in a conventional STP, we have a screen that will remove big inorganics, suspended inorganics. Then grid chamber, again it will remove the inorganics. Then we have a primary settling tank. It will remove the suspended organics. Then we have a aeration tank to remove the soluble organics in the secondary sedimentation tank. Right? So they are saying aeration tank will be placed between primary settling tank and secondary settling tank or secondary sedimentation tank. So between primary sedimentation and secondary clarifier is the answer. Answer is right after secondary clarifier is next to it. It's not, it's wrong, right? So A is not correct. Right before sand filter is also wrong. So we need before secondary settling tank, but after primary settling tank. So aeration tank should be placed between primary and secondary clarifier. See this, you will understand. Primary settling tank, secondary settling tank, aeration tank is placed between. So that's the treatment system, right? Right to, it's not right. Right will be tertiary, advanced treatment system. Please correct your answer, sir. I'll go to the second question. Which of the following is a major challenge in adopting constructed wetland for sewage treatment? Major challenge they are asking, disadvantage. Larger area requirement, complicated construction. No, it's a easier construction only because simply the plant you can use, sand you can fill, wastewater we can open. Only the pipe at the end we need for collection. There is no mechanical energy, nothing is required. So it's a simple construction. Intricate operation and maintenance, nothing, no operation maintenance. The plant will simply grow. Expensive to build, not that much costly. Cheaper, right? Land area is, if you want, you have to have a bigger area for higher degree of. You can optimize with the smaller area also. That type of research is required. So we are working on constructed wetland optimization processes and all nowadays. Also, we have also incorporated some of the carbon sources to act as a denitrifying agent. So that's what our research focus also. One of our research team is working on constructed wetlands. So the problem is large area requirement. See, limitation is large area, but it is very cost effective, simple operation, simple construction. Okay. Okay. So the plant uptake or absorption process in wetland can remove. So wetlands will remove mostly organics, inorganics, metals, nutrients, pathogens, everything it's removing. But which process is happening for which pollutant removal is there, right? So plant uptake and absorption process will remove what plant will absorb? COD, BOD, suspended solids, nutrients, all the above. No, not all the above. Plant will take the nutrients. Wait, absorption. COD, BOD, suspended solids will be used for absorption is fine. COD, BOD is also fine. Nutrients are all the above. Nutrients, yeah, that is correct. Because plant will uptake mostly the nutrient. It will not take that much of organics. Organics will be treated by the microbes present in your soil, right? Plant will take only the nutrients. So you can see here, plant uptake and matrix absorption will happen for both phosphorus and nitrogen, that are nutrients in my wastewater. But as I mentioned, suspended solids will be removed by sedimentation and filtration, not by plant uptake. Similarly, BOD and COD, soluble organics, will be removed by biological degradation, microbial degradation, not by plant. You got it? So that is the principle behind the wetlands. Please remember. Okay. Fourth question. In addition to being inert, the biofilm carriers in MBBR should have, as I mentioned, MBBR, moving bed bioreactor. Because in the moving bed, microorganisms are growing. So moving bed bioreactor. So how the bed should be? What are the configurations of the bed? It should be inert, like plastic or any inert media. It should be. Along with that, we have some more parameters, right? High surface area, yeah, it is required. Low density compared to the water. Is it should be high density or low density? It should float in the water, right? High surface area is correct. Density close to the water, that is also correct. Low surface area is wrong. Because of why it need high surface area? Whenever there is a high surface area, if it is a simple circle, then only this area is like available for the microorganism growth. But instead of circle, if it is having larger sections, then microbes will grow in here, 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 here. So everywhere it will grow. Similarly, if you have some more cross sections, so microbes will grow here, here, everywhere it will grow. So you have to increase the surface area. That's why, see, all the reactors are having the carriers, biofilm carriers are having surface area, increased surface area or different shapes. Similar things are happening in absorption process also, right? The microbes are attached to the surface of the biofilm carriers. So the requirement is it should be inert, it should have a higher surface area, its density should be close to the density of the water. Why? It should be floating, it should not settle because the microbe should be suspended. The microbes attached to the biofilm carriers are should be in suspension. So HDPE we are using to maintain the density. Okay. Can you guess what type of MBR is this? MBR, membrane bioreactor. So we have a membrane. We have a tank, aeration, microbes will grow. Where we are placing the membrane? Inside, outside, outside air type. Based on that, we have classifications, right? So hollow fiber MBR configuration, external MBR configuration, submerged MBR configuration, airlift side stream MBR configuration. So it's submerged. So that is correct. It's not external. It's a external or internal. Airlift. Actually, it's airlift only. It's a side stream or not? Side stream is separate tanker, right? Internal. It's internal. Okay. So let's see the answer. It's external because there is a uh, wall here in between the reactor. So it will be considered as the second reactor. So this will be aeration mixing. Here aeration. The third tank will have the membrane. So it's the external kind. But the external is submerged, right? This is also in submerged condition. So you can choose this also. But it should be aerated. Are we aerating this? No. It's not airlift. It's not submerged. It's actually submerged. But submerged is the internal submersion. So this is also wrong. See, submerged is internal in the same reactor. So it will come under external side stream. You got it? So this is internal, sir. Submerged is internal in the same reactor. Once you have a wall between the membrane and the reactor, then it's external. Please correct. So it's external. Actually, it's confusing by seeing the image. But if it is a wall, it's external. If it is having a air, then it's a air lifter. It's not having air, so it's external MBR. Can be simple. Okay. Okay. So sixth question. Match the components of a construction wetland with their suitable examples. Microfiber, substrate, liner. We have for a constructed wetland, we need a inlet, we need a outlet, we need a substrate, wastewater, and the media, the base, the liner at the bottom, the plant, microphytes are the plant, right? So these are all the requirement. So what are the things we can use for the microphyte? For the plant, what can we use? Water lilies, right? We can use water lilies at the microphyte because it can be suspended on the water. It can also go up to the soil. So water lilies can be used. Substrate. So sand can be used as a substrate. Plastic can also be used as a substrate, but plant will not grow in plastic. So sand is a good substrate. So sand we are filling here. Then liner. Liner is a plastic because the water going to the ground it's retarded here. So plastic need to be here. So B A C. A is correct. Yes. So correct. See, we need a substrate that can be a sand here or gravel. We need a vegetation that can be any plant like a hyacinth, water hyacinth, water lily, Canna indica. Canna indica, you know, right? Some kind of banana kind of leaf will be there. So that will be Canna indica plants. And then outlet and inlet can be a pipe, PVC pipe. Liner can be a plastic liner at the bottom. Basin will be a concrete reactor. Okay. Which of the following description is correct about SBBR? Sequential batch biofilm reactor. SBBR is a SBR combined with the biofilm growth on the surface of a inert medium as a biofilm carrier. Is it correct? Yes. Because it's similar to SBR combined with the biofilm growth on a inert media, surface of the inert media. That is correct. Yes. Second option. SBBR is like an ASB having inert media. No, we don't have two reactors. It's a single batch reactor. It's not continuous. ASB is a continuous reactor. It's a batch reactor. Once fill, it's stopped. But ASB is continuous. SBBR is analogous to MBBR. No. There is no membrane. There is no continuous flow. Operated in sequence of batches. No. There is no membrane or there is no moving bed. A moving bed is there, but it is not a continuous operation. All the above. That is also wrong. So option A is correct. It's equivalent to SBR, but the difference is having a biofilm carrier. Okay. So SBBR, that's the answer here. Combined by similar to SBR, combined with the biofilm growth. Eighth question. We have two statements. Can you say which is correct? Statement A. MBR is essentially a combination of aeration tank and secondary settling tank followed by a membrane filtration. A combination of aeration tank and secondary settling tank combined followed by a membrane. Is it correct? Yeah, correct. Similar to ASP only, but all are in a single tank. Instead of settling, we can use membrane as a retarding agent. Statement 2. In MBR, RO membranes are used for filtering solid biomass from the treated water. RO membrane or any membrane we can use. Actually, MF and UF we have to use. RO is too much. So, we can say statement 1 is correct. Statement 2 is incorrect. Because it's a combination of similar to ASP, but aeration is happening continuous flow only, but a membrane we are using to retard. But the membrane we are using is micro filter and ultra filter, not the RO. That much, because RO will easily clog. RO can be used to treat drinking water, like salt and all we can retard. Okay, ninth question. Which of this process does not involve biomass growth on inert media? Inert media will be used in SBBR, MBBR. That's it, right? MBR will not use any biofilm. Constructed wetlands will not use any inert media. So the answer is, which of the process does not involve biomass growth on inert media? Actually, MBR is correct. MBR is do not involve only. In constructed wetland, do we have an inert media? They are talking about the sand as an inert media. Okay. Sand as an inert media. So the most suitable answer is MBR. In constructed wetland, sand can act as a inert media and the microorganism will grow on the sand while the water is coming in and the water is taken out. Okay. SBBR will have a biofilm. MBBR will have a biofilm carrier or inert media. You're also inert media, right? Yeah. 10th question. Please post your answer in the chat box. A complete disinfection can be achieved through constructed wetland, SBR, MBBR, none of the above. Are we using any of this for disinfection? To remove the microbes? All are biological treatment system. So microbes will always be there in all the systems. So it's not a disinfection process. After the treatment, the effluent is taken out and we have to use a separate disinfection process or a tank or a plug flow condition. So none of the above is correct. You got it? Yeah. So next 5 question is based on this figure. Okay. So the adjacent figure shows what type of treatment system is this? SBR, right? Sequential batch reactor is the one tank at a different time. It will act at a different system in a single reactor. So they are asking which is settle. Which is settle? What is A? Fill, because we are filling the wastewater. It's a fill. What is B? We are putting aeration, we are putting mixing. What is this? React. What is C? After reaction, it need to be settled. So settle is C. What is D? After settling, the pure water will be taking out. So that is a decant. What is E? What is E? After taking the wastewater, water should be here actually now. Water will be here at this stage. Water will be fully reduced. Only sludge will be there. That sludge will be mixed for the next cycle. That is called ideal stage. Yes. So they are asking which is settled stage. What is the answer? Choose from this option. Yeah, B is correct. Okay. So okay. See the same reactor I am giving again. Major removal of BOD takes place at which stage? I'll go back here. Major removal will happen. BOD removal. Where it will happen? BOD removal will happen only during reaction, right? Where the reaction is happening. From this option you can choose. Stage B. The option is also B. Stage is also B. So during react phase only maximum BOD removal will happen. Okay. Next. Which of the following stages require air pump? During filling we can use air pump. Okay. During reaction we can use air pump. Okay. Settling we should not use any pump. Decant also we should not disturb the surge. Final stage we can use the air pump. So A, B and E we can use the air pump. We can use this phase and this phase we can optional. But reaction should requires air pump and mixer. So option D is correct. Right? See the E. They are asking air pump. Sorry, option is A, B, E. This is not the option. This is the correct answer. Please check. Let me check. Let me change. You got it? Sorry for that. Actually, A, B, E is correct. This three requires aeration. Okay. Can you answer the 14th question? Stage B represent. What is this stage? You have already seen. This is a decant stage. Yes. This is a what stage is D? Decant stage. Final question. Waste sludge is withdrawn at where we will take out the sludge and the remaining sludge we will use for the next cycle. At the end, which stage is that? Ideal stage. What is that? E. So option D is correct. Okay. There only we will take out the excess sludge. See here also water is taken out. Here the sludge is taken out. That's why there is two arrow mark. Here there is a arrow mark to fill. These two that's a batch. So once filled until taking out we should not again fill. That's a batch reactor. That's why SBR. Okay. Rest of one. The treatment stage with this overall clubbing like ultrafiltration and reverse osmosis coming under primary, tertiary or secondary. Anaerobic lagoons will come under. Equalization and sedimentation will come under. So as I mentioned first, you have put our microphone off. No, you can unmute and you can talk. Yeah, you can talk, sir. Hello. Actually, your microphone is not working, I guess. Ravikant sir, can you talk? Can you able to do? I didn't muted anyone. You can unmute and you can talk. If your microphone is having problem, you can put it in the chat box. Do you have any doubt? Let me wait. You please unmute and in the microphone you select which headphone you are using. In the microphone options, you can select which type of headphone you are using. Okay. Or you please type it in the chat box. Okay, okay, let me move on. So first is uh, screening, grid removal, primary settling fan, ASP or aerated lagoon or MBR, these are all. Then tertiary treatment like filtration, RO and all. So this will come under primary or preliminary. This will come under secondary, ASP or aerated lagoon. Tertiary will come under reverse osmosis or ultrafiltration, any kind of filtration tanks. So equalization and sedimentation will be the primary, aerated lagoon or anaerobic lagoon will be secondary, ultrafiltration will be tertiary. So the option is 2, 3, 1. A. Okay. Yes. See this whole flow chart. Second question. Which of the following treatment processes are mostly likely to occur in constructed wetland? Adsorption will happen, yes. Phytoremediation will happen. Bioaccumulation will happen. Sterilization will happen? No. Because it's not pathogen removal. Then chemical precipitation, that will also not happen, I guess. Yeah. Filtration will happen. So A, B, C, F. So I think option D. Did you got it? See that list: adsorption, filtration, hydrolysis, biodegradation, bioaccumulation, phytoremediation, and photoremediation will happen in the natural as well as the constructed wetlands. Not sterilization, not chemical precipitation. We are not adding any chemicals. It's a natural process, right? Okay. Nitrogen and phosphorus removal are likely happening to be removed from the constructed wetland by what are the principles? As I mentioned, nutrients will be taken up by plant. Also, matrix absorption will also happen in the nutrient removal in constructed wetland. So both A and B are correct. You got it? Yes. So matrix absorption, plant uptake for both nitrogen and phosphorus nutrients. Which component of a constructed wetland is majorly responsible for the removal of contaminants? Which component of constructed wetland? We have in system, we have a out system, we have a liner system, we have a reactor system, I mean the tank, we have a substrate, we have a I mean the base, we have a plant, that's it, right? So which component? Under drainage system? No. Substrate media, only substrate media? No. Vegetation and substrate media, because substrate media will act as a filtration and sedimentation, vegetation will act as a nutrient uptake. So this is correct. Only vegetation is also wrong, only substrate is also wrong. Under drainage system is not having any role. So option C is correct. All this will act as a simply mimicking the natural wetland system. That's why it's called Earth's kidney for the treatment of purification of water. Okay, so the substrate media and vegetation both will help in the treatment system. Okay. Which of the following statements are correct regarding different types of constructed wetland? We have surface flow and subsurface flow. In the subsurface flow, we have surface, subsurface, horizontal, vertical, based on the flow. Okay, they are saying a free water surface, that is a surface water. Water will be there. Constructed wetlands is mostly likely to replicate the natural wetland. That is correct. Yeah, this is correct. A wastewater influent flow horizontally through the basin in a horizontal subsurface flow, constructed wetland. So in a horizontal subsurface flow, water will flow horizontally. That is correct. In a vertical filter stage, the horizontal filter stage may be combined in a hybrid wetland. Both vertical filter stage and horizontal filter stage combined together are called hybrid. So that is also correct. So all the above. So the answer is all the statement about constructed wetlands are correct. You got the whole system? Yes. So free water surface is simply replicating the natural. First statement is correct. In the horizontal flow, water will flow horizontally through the basin. In vertical flow, water will be pushed from top to bottom. In a hybrid, both vertical and horizontal matrix will be combined. Okay. Sixth, identify the most appropriate option for statement A and B. Okay. A is subsurface flow. Constructed wetlands can either be horizontal flow or vertical flow. That is correct. Surface flow, subsurface flow, horizontal, vertical, again combined or hybrid. Okay, so subsurface can be classified into vertical, horizontal. That is correct. Wastewater is poured or dosed onto the surface from above using a mechanical dosing system in horizontal surface flow type. That is wrong. In a vertical flow type only, water is pushed from the top. In horizontal, there is no pushing. Through gravity, side slope, water will flow. So, it's a vertical subsurface flow only. Water will be dosed or poured from the top. So, 1 is correct, 2 is false. A is true, B is false. Okay, are you getting? If you have any doubt, please post it in the chat box. See, horizontal, vertical, hybrid. You can also merge along with the surface flow. In the vertical flow only, we have the wastewater is poured or dosed on the surface above the mechanical dosing system, through the mechanical dosing system. Okay. In a sequential batch reactor, SBR, sludge blanket is majorly generated in. Where the sludge blanket will happen? What are the stages? First, fill. Second, react. Third, decant. Fourth, third, settle. Fourth, decant. Fifth, idle. Again, we are filling. So, this is a continuous cycle, sequential batch reactor. Which stage? Sludge will be settled and there is a sludge blanket. So, settling stage only, sludge will be settled and there is a sludge blanket. So, settle phase where the sludge blanket will majorly generate. You got it? In the settle stage, sludge blanket will be formed and the top will be clear supernatant. That can be taken out in the next stage, that is a decant stage. Clear effluent. Okay, eighth question. Which of the following is not an integral component of SBBR? Sequential batch biofilm reactor. So what will not be the part? Aeration for oxygen supply. In a sequential batch reactor also we need a air, right? Along with the biofilms. So air is required, that is correct. Biofilm growth on a media. So media is required, that is also correct. Membrane for solid liquid separation. Do we need a membrane in SBBR? No. In MBR, there is a membrane. Microorganism for organic matter decomposition. All the microorganisms will grow on the surface of the media and some will be on suspension also. So microorganism is required. It will be their integral component. Which is not integral component? Membrane. Membrane will be there in MBR, membrane bioreactor. Okay. Fine. Ninth question. Identify the correct pair concerning the different scenarios of fill phase. In SBR, we have 5 stages. Out of this, the first phase is fill type. During filling, do we need aeration? Do we need mixing? Based on this condition, we can classify into static fill, mixed fill, or aerated fill. Can you classify? Can you correct the pair? Static fill. There is no mixing, no aeration. In mixing fill, only mixing will be there, aeration will not be there. In aerated fill, both mixing and aeration will be there. Can you check now? Partial mixing, so it's wrong. Mixed fill, no aeration, full mixing, that is correct. Aerated fill, high aeration, no mixing. That is also wrong. So mixed fill with no aeration and full mixing is correct. They are asking which is the correct pair. During fill type, fill phase in SBR. You got it? During filling, do we need mixing? Do we need aeration? Based on that, we can classify into static fill, mixed fill, and aerated fill. Okay. See, static fill, no mixing, no aeration. Mixed fill, no aeration, but mechanical mixers will be there. Aerated fill, both the aerators and the mechanical mixers will be there in active condition. Okay. 10th question. Different stages and which is removed. During react phase, which is removed? BOD will be removed. Organics will be removed. During decant treatment, water will be taken out. Treated water. During ideal phase, excess sludge will be taken out. Wasted. Other waste sludge. So 3, 2, 1. Option C. You got it? Fill stage, nothing will be taken out. No out thing will be there, right? In react stage, all the organics will be converted into gas and sludge. So there is a arrow mark out. So removal of BOD. During settle stage, there is a down arrow mark. During decant stage, there is a top out arrow mark because top water will be taken out. During ideal stage, there is a bottom arrow mark. Sludge will be taken out. Some sludge will be taken out, that is wasted sludge. Some sludge will be retained for the next cycle. So there is a 2 arrow mark here, 1 arrow mark here. You got it? Yes. 11th question. Identify the incorrect statement. An FBR requires a continuous supply of energy for its operation. Yes, we have 5 stages. For 5 stages, we have energy requirement. When an SBR is combined with the biofilm growth, the surface of the support media, it is called a MBR. No, it is called SBBR. Sequential batch biofilm reactor. In the SBBR, the biomass grows on the film on a small plastic carrier that moves freely in the wastewater. That is correct. So, which is the incorrect statement? Only statement 2 is incorrect. You got it? Yes. 12th question. A possible cause of low treatment efficiency in MBBR. In India, we have used MBBR as I mentioned. We have a lots of trial and error methods. I mean, lots of construction happened and we have a lots of experience. Based on our experience, what is the lower treatment efficiency possible causes? We have a lowest dissolved oxygen. That is one problem because it requires lots of oxygen. Clogging of biofilm. Higher concentration of oil and grease. That is another problem. So these three all are the problems with the low treatment efficiency in MBBR. See, oil and grease, if it is there, there is a limitation of the MBBR. Dissolved oxygen is very essential for the effectiveness of biofilm. We are not supplying that much. Clogging of non-availability, because primary settling tank is not there, there is a clogging problem. These three are important limitations of MBBR in India. Okay. 13th question. Biofilm based biofilter process combined with the activated sludge process. So ASB, there is a aeration. So ASB means aeration will be there. Biofilm. Biofilter. So there is a biofilm and the biofilter. What is this called? MBR or MBBR? ASB combined with the biofilter. So there is a membrane, biofilm. So there is a MBBR, I guess. Yes. You got it? There is a biofilm, there is a aeration similar to ASB, there is a membrane, MBBR. Hope you got this with the name itself. Moving bed. So there is a biofilm, biofilter, bioreactor. Moving bed with the membrane. You see, combination of conventional ASP, biological treatment, biofilter process. Attached growth. 14th question. DAS are used to perform a solid liquid separation in MBR. In MBR, after similar to ASP, we are supplying oxygen. All the microbes will take this organics coming in. Then ASP we will settle. Instead of ASP is settling, we are adding a membrane that will block the sludges. So to perform solid liquid separation, we are using a low permeable, low pressure membranes like MF or ultrafilter, microfilter or ultrafilter we are using. So low pressure membrane we are using in MBR for solid liquid separation. Clear water will come out. You got it? Yes, we are using a low pressure membrane like microfilters and ultrafilters. Final question. The degree of fouling in MBR is usually independent of. So membrane fouling is A membrane will have different size of pores. The pores will get clogged by the flocks or by the salts or by the microbes or by the anything, it will clog the membrane. So if it is pore clogging and then pore narrowing, pore pore will be clogged, or there is a cake formation. These are all different flock formation in MBR. So it's how the flux will formation factors affecting the flux formation will be the influent water characteristics. So that is correct. And the operating condition, that is HRT, SRT and all. And the membrane properties, right? Which is independent of subsequent tertiary treatment. That is independent of, because whatever we are doing subsequently, that is not depending on this membrane fouling. So membrane fouling is not depend on, sorry, membrane fouling is not depend on the subsequent treatment. It's based on the operating condition of MBR, the wastewater characteristics, inlet wastewater characteristics, and the membrane pore size properties and all. You got it? So which is independent subsequent tertiary treatment. So the factors affecting membrane fouling is membrane characteristics, operating condition, and the wastewater characteristics and biomass characteristics. You got it? So today we have discussed about the constructed wetlands, SBR, SBBR, MBR, and MBBR. This is the alternate option to the conventional treatment systems. Hope you got a clear view on this. So we are in the final stage. So only 11 and 12th week are pending. So please give your assignments if you have applied for the examination. Prepare well for the examination. I have opted for an extra class, that is the 13th week, to discuss some more problems like what we are doing for this 12 weeks. Our 2025 assignments I am going to discuss in the 13th week. The NPTEL team will give you the date and the link. Okay. So please follow up and do your assignments before Wednesday. Thank you all. Thanks for joining today. If you don't have any doubt, you can leave the meet, or I will be here for 5 minutes. You can clarify your doubts. Thanks for joining. Thank you all. Yes. Hope you don't have any doubt. Let me close the meet. Thank you.